in your ISNs on page 90, you should have put the intro to quadratic functions. I'm going to give you the notes. You need to make sure these are copied into your ISN, and then I'm going to let you do the inside on your own. So a standard form of a quadratic equation, we've talked about a quadratic equation before. It has an x squared. The highest degree is x squared. In standard form, it is written a times bx squared plus bx plus c. These are the numerical coefficients in front of the x squared and x term. This is called the constant. The shape of this type of equation is called a parabola. Looks like a little happy U. Okay, so this right here, the blue line that you're seeing, is a quadratic equation. It's a parabola. There are a few things that we need to be able to identify on a quadratic equation. One is this red dotted line that they've indicated. You need to be able to write the equation of a vertical line, and it is when x equals -2. In this case, look where x is, 1, -2. If we folded the parabola on top of each other, it would be symmetrical. This line is called the axis of symmetry. So you're looking for the point where you could fold it, or the line where you could fold the parabola on top of each other, and you need to be able to write the equation of that line. There's another point that you have to identify, and it is going to be either the lowest or the point. It's where the slope changes from a negative slope to a positive slope. It is called the vertex. We've used that word before when we're talking about corners. It's the point where the slope changes, and it will be the lowest point or the highest point. In this case, those coordinates are when x is going to be -2 and y is -2. So this is the vertex for this parabola. When the vertex is the highest point, it is called a maximum. When it is the lowest point, it is called the minimum. This one on this graph would be a minimum because it's the lowest point on the graph. So then we can use that to help us decide what the range when we're looking at the y. There's another thing that we're going to identify on these quadratic equations, and it's the solutions. The solutions on a quadratic equation are the x-intercepts. And if we remember x-intercepts, that is when y equals 0, when it crosses the x-axis. There are going to be two solutions. There's another name for these solutions, and those are called the roots of the equation. So fill out your ISN, and then I want to look at a few parabolas or quadratic equations that you need to be able to recognize all this stuff. So pause while you fill in these notes. And then I'm going to look at some more problems. Here's another parabola. We should be able to identify the axis of symmetry. It is the point, the line, where you could fold it, and it would be symmetrical. It would fold on top of each other. So the axis of symmetry for this first equation is, again, it's a vertical line, and it's going to be when x equals -1. The vertex, that's the lowest point. So you would write the coordinates for that. So if you see you're looking at x is -1, y is actually equal to -5. And this vertex is going to be, again, it's the lowest point, so it's a minimum. And that helps us define our range, which would be when y had to be greater than or equal to -5. It's those y values. It's everything from -5 up tells me the range. The last thing that you're going to have to be able to identify are the zeros. How many are there? Well, you're going to look at the x-axis. There's actually 2 in this case. There are 2 zeros. You need to be able to identify those points. It actually goes through the origin 0, 0, this particular graph, and it goes through the point when x is -2, y is 0. So when you're actually writing the points, y, of course, is always going to be 0 for those zeros or roots, or they may ask for solutions. It's all the same thing. In this case, there are 2, and they would be at 0, 0, and -2, 0. The last thing that you have to be able to identify is the domain, Because these arrows indicate that this graph is going to go on and on, you would say x is a real number. X is a real number. You could say x is in the set of real numbers, and that notation just looks like this. So we should be able to look at any parabola and see that. Look at this one. Okay, it's a parabola. You would fold it on this axis. So if you were looking for the axis of symmetry, you would say that is when x actually equals, so you could write it right here, x equals 3 this time when I'm looking at my coordinates. The vertex is right here. It's the lowest point, so it's going to be a minimum. And it is actually, you would just write the coordinates of that point. X is 3 and y, of course, is 0 on this one. Then, if you're looking for zeros, this parabola only actually has one intercept. It only hits the x-axis at one point. When x equals 3, y is 0. The domain, because of the arrows, that would be x is in the set of real numbers. And the range, y would have to be greater than or equal to 0 on this graph. So this parabola has a minimum that only has one solution. If you were looking at a different parabola like this one, oh, this one has been reflected. Oh, we might want to remember that idea. A reflection meant that there was a negative number somewhere. This reflection creates a parabola that goes upside down. We can still identify all of these things. The axis is actually the y-axis, or the axis of symmetry, I'm sorry, is the y-axis. And to write that equation, that's when x equals 0. That is the equation for the y-axis. X equals 0. Doesn't matter what y is, x is 0. The vertex, look on this case, this is where it changes from a positive slope to a negative slope. This is the first time we've seen it. This vertex is going to be a maximum because it's the highest point on this graph. This vertex is going to be at the point when x equals 0, y is negative 1, and it would be a maximum. In this particular graph, it never actually crosses the x-axis, so you have no zeros. That means there are no roots. There is no solution on this graph. The domain, again, because of those arrows, that means that x would be in the set of real numbers. Okay, and the range, well, this time, because it's flipped, the parabola is a reflection, and look at where the y values are. It only goes in this direction. Y is actually going to be less than or equal to -1. Those are your possible y values, and it never goes above -1. So you should be able to look at a parabola and identify all of these things. When you open up your foldable, you're going to see some problems. I want you to do these for your homework on your own, and I will put the answers either in class notebook or we'll go over them tomorrow. So that's quadratics. That's your intro. We'll see you in class.